Before we start this lesson, everybody should have a copy of the Lesson 4.1c continued worksheet. The substitute was supposed to pass it out, so hopefully you have it. Grab your pencil, and we're going to take a look at 6 one-step and two-step equations. So the directions are to solve each equation algebraically. We're going to solve without a model. And be sure to show all of our algebra steps. And once we have our solution, we want to check it and make sure that it works. So for the first one, we've got x minus 4 equals negative 1. The first thing we want to do is rewrite it as an addition equation. So x plus negative 4 equals negative 1. Now remember, the goal when I'm solving an equation is to isolate my variable on one side of the equation. And so I need to move the negative 4 to the other side. And I can do that by adding the opposite of negative 4, which is positive 4. If I add it to the left side, I must also add it to the right side. And I've got my opposites, which are going to leave me with just x on the left. And on the right side, negative 1 and positive 4 is 3. So I've solved the equation because I've isolated x on the left-hand side. Now that I've solved my equation, I can check my solution. So the first thing that I write down is the original equation that I was solving, x minus 4 equals negative 1. In place of x, I'm going to put my solution, which is 3. I'm also using the definition of subtraction to rewrite subtraction as addition of the opposite. And I can see that 3 and negative 4 would give me negative 1 on the left, and I also have negative 1 on the right. So our solution is correct. All right, for number 2, we have negative 2x equals 20. And I'm going to rewrite the equation so that I'm not working off of the original. Now, I do have just my variable term on the left side, but I want to know what one of the x's is equal to. So I can show my work one of two ways. I can either multiply both sides by negative 1/2, or I can divide both sides by negative 2, and I'm showing division using a fraction bar. On the left side, negative 2 divided by negative 2 is positive 1, so that will leave me with x. And on the right side, 20 divided by negative 2 is negative 10. So we've isolated the variable on the left side. We know that x is negative 10, or we think it's negative 10, and we're going to check our solution to make sure that it works in the original equation. So I've written the original equation, and now I'm going to replace x with negative 10. And of course, 2 times 10 is 20, and a negative times a negative will give us the positive 20 that we're looking for. So we have a correct solution, and on to number 3. For number 3, I have a two-step equation, so there are two things I'm going to have to do to isolate my variable on the left side. The equation is addition, and so I don't have to rewrite it because it's already addition, but I am going to rewrite it so that I'm not working off of the original. So I do need to isolate my variable term on the left side, and in order to do that, I'll want to add the opposite of positive 1 to both sides. So the opposite of positive 1 is negative 1, and if I add negative 1 on either side of my equation, I'll have just 2x on the left, because positive 1 and negative 1 will give me 0. And on the right side, 11 and negative 1 will give me 10. At this point, I have 2 x's on the left side, and I want to know what 1 x is equal to. So, like the previous equation, I can show my work one of two ways. I can multiply both sides by 1/2, which is the reciprocal of 2, or I can divide both sides by 2. Because I used division last time, I think I'll use multiplication by the reciprocal for this one, just to change it up. So if I multiply both sides by 1/2, in other words, I want half of each side, half of 2x is x, and half of 10 is 5. So we've isolated our variable, x is equal to 5, and we'll plug it into the original equation to make sure that it works. The original equation was 2x plus 1 equals 11. In place of x, I'm putting my solution, which is 5. And now I need to simplify on the left side. So using order of operations, I multiply first. 2 times 5 is 10. And then I can add 10 and 1, which gives me 11, which is what I have on the right-hand side, so good news. All right, number 4. So x divided by 4 minus 3 equals negative 1. I'm going to use the definition of subtraction to first rewrite as addition only. And I want to isolate my variable term, this x divided by 4, on the left side. So for that to happen, I can add a positive 3 on the left, which means I have to add a positive 3 on the right. Of course, my negative 3 and my positive 3 will give me 0, and that leaves me with x divided by 4 on the left side. My negative 1 and positive 3 will give me 2 on the right side. Now at this point, remember what this means. This means we have the variable x divided into 4 parts. And so a fourth of x is equal to 2. We want to know what the whole x is equal to. So that means I need to multiply by 4 because 4 fourths will give me 1 whole. And if I multiply by 4 on the left side, I have to multiply by 4 on the right side. Now, of course, my 2 4s will simplify. In other words, 4 fourths is 1 whole. That gives me x on the left. And on the right side, I'm multiplying 2 by 4, which is 8. So we think that x is 8. Remember, we'll check our equation and we'll know for sure. So I'm rewriting my original equation, x divided by 4 minus 3 equals negative 1. In place of x, I'm putting my solution, which is 8. I'm also going to rewrite as addition, so using the definition of subtraction. And using order of operations, 8 divided by 4 is 2. And 2 plus negative 3 will give us a negative 1. So negative 1 on both sides. Good news, our solution is once again correct. All right, we're down to the last two. For number 5, the first thing I'm going to have to do is clear those parentheses. So like we learned in Module 3, we want to use the distributive property in order to do that. So I have 3 groups of x plus 5, which means I have 3 groups of x, or 3x, plus 3 groups of 5, or 15. On the other side, I have 75. Now that I've cleared the parentheses, I can work on isolating my variable term, my 3x, and that means I'm going to want to add the opposite of 15, which is negative 15. So I'm adding negative 15 on either side of my equation. I'm using an additive inverse in order to isolate the variable term. 15 and negative 15 will be 0, so on the left side only the 3x remains. On the right side, I have opposite signs, so 15 zero pairs and 60 will be left over. At this point, I have 3 x's and I want to know what 1x is equal to. So I could divide both sides by 3. I could also take 1/3 of each side. So my choices are multiply both sides by 1/3, or I can divide both sides by 3. I think I'll divide both sides by 3. I'm showing division using a fraction bar. Of course, on the left, 3 divided by 3 is 1, and 1 times x is x. That's our identity property of multiplication. And on the right side, 60 divided by 3 is 20. So x is equal to 20. We'll know for sure once we plug it back into our original equation and check it. So I have 3 groups of x plus 5 equals 75. 3 groups of 20 plus 5 equals 75. At this point, I could distribute the 3, or I can just use order of operations. And if I simplify in parentheses first, 20 plus 5 is 25. And now I'm going to multiply by the 3, which gives me 75 on the left and 75 on the right. So good news for us. And we're on to the last one, number 6. So for number 6, I have my variable term 3/5 x isolated on the left side already. So I don't need to use an opposite. What I do need to do is figure out what 1 whole x is, and right now I currently have 3/5 of an x. I could divide both sides by 3/5, but if I do that, on the left side it might not be so bad, but on the right side we might look at that and think, what are we going to do with that? So instead of dividing both sides by 3/5, it might be a better idea for us to use a reciprocal. So the reciprocal of 3/5 would be 5/3. And notice that if I multiply across, I'll have 15/15, which is 1 whole. Or I can cross reduce the 5s, and I can cross reduce the 3s, and I still have 1 whole, and 1 times x is x. Now if I multiply the left side by 5/3, I have to do the same on the right side. And it might be helpful to put 9/1 so I have 2 fractions. I can multiply across 45/3, which will simplify to 15, or I could cross reduce the 3 and the 9, and notice I still get 15 when I multiply and simplify. So x is equal to 15, and now for our check. 3/5 of x is equal to 9. We think that x is 15. So in place of x, I'm going to put 15, but because I'm going to have to multiply it by 3/5, I'm going to put 15/1. Again, 2 fractions, easier to work with. I can multiply across. I would have 45/5, and 45/5 is 9. Or I can use some cross reducing. 5 goes into 15 3 times. 5 goes into itself once. And I'm going to have 9/1, or 9. So 9 is equal to 9, and that means that x equals 15 is the correct solution. So just wanted to go through some 1-step and 2-step fairly common equations that we should be able to solve, remembering that we've got a quiz on solving equations coming up next week. So this worksheet, now that we've completed it, is going to go after page 23 in Module 4, just a little extension of Lesson 4.1c. And as soon as you're ready, we're going to go on to 4.1e and solve some equations that are a little bit tougher because we're working with fractions and some decimals. Okay, we are going to skip 4.1d, so we will not be completing that lesson.